Yeah, before we go into where we are now and where we are going next, I just wanted to take a step back. And in our field, finding a problem was not a problem. We have a rising demand with an aging population and a limited resources with a shortage of staff. And in this day and age, with large language models and ChatGPT, we very much have the situation where we start with the AI technology and then we try to find different problems which we can apply that technology to. But in our field of medical imaging, it's been very much the other way around. We've had the problem of trying to automate segmentation for a long time, and we've had other solutions for it previously. So, for example, we've had atlas-based segmentation, which some clinics are still using today. And for this specific problem of segmenting images, deep learning emerged as the solution. And there were a few things that enabled this solution to happen. So one of them were the evolvement of new algorithms. So the UNet came out in 2015, which is a neural network. And to this day, that is the algorithm that is most commonly being used with slight variations. And if we talk like AI time, that was a long time ago. It's 10 years ago, but to this day, that is what's being used. We also roughly at the same time had an exponential growth in compute power, as well as an exponential increase in medical image data. And then 2017, RaySearch established the ML department, which does several different things. I will touch on some of the other bits. But what I'm working with then is deep learning segmentation, which you can see here briefly in the image. And also a big part that has enabled this solution to be as successful as it is today. And this doesn't only go for machine learning and deep learning segmentation, but also RayStation and RaySearch as a whole. And that's the close collaboration we have between in-house and external specialists. So when we're talking about deep learning segmentation, that's machine learning engineers, of course, but also radiation oncologists and RTTs and similar clinical specialists that we work very closely with, as well as medical physicists. So what is actually our solution? So we offer 199 structures as of RayStation version 2025, which was released now in April and has been submitted to the FDA now. We have both CT and MR models, and we're developing this at a high speed. So for version 2025, we released 92 new or improved structures. And we're not only developing this at a high speed, the model itself is also very fast. So we can segment a full body scan in under a minute, and that includes 192 structures, which is the number of structures we have in our CT model. And the CT model covers both brain, head and neck, thorax, breast, abdomen, and the pelvic region, and it includes lymph nodes for male pelvic, breast, and head and neck. We also recently, for version 2025, released our first MR model, which covers the male pelvic region. And here you can see an interactive view of the model, which you can also use over there, or you can also book a demo to have an even closer look at it. We have a lot of structures, but we also have a lot of users. So right now we have 300 clinics using our deep learning segmentation solution. And we have seen this number of clinics and the number of patients being treated with deep learning segmentation grow quite rapidly over the last few years. So in 2022, 20,000 patients were treated with deep learning segmentation. 2023, that were 5 times doubled to 100 patients roughly. And last year, that number was up to 200,000 patients. And we expect this number to continue to grow as we get more clinics and also get cleared in more markets, and as we also add even more structures. So that is where we are today. So where are we going next? So what we're focusing on now is getting full RT coverage on both MR and CT. And what that means for the CT model is female pelvis, which includes lymph nodes and other structures such as the parametria and uterus cervix. It also includes prostate bed, which we are working on 2 different versions of, the full bronchial tree and the bowels. And that's some previews you can see here in the images. So we have the female pelvis lymph nodes, which we have a first version trained on. We also have the bowels, which we have recently trained, as well as 2 different versions of the prostate bed. We're also working on covering more parts of the body for MR, so we're currently working on brain and female pelvis. And these are all projects that are ongoing, so they're not happening in a faraway future. All of these are currently being developed, and I think most of them, or at least several of them, are training as we speak on some of our GPU servers, which is fantastic. But at the same time as we're developing new structures, we're also continuously working on the existing ones that we have. And we currently have 2 streams going here. And one of them is improved support for pediatrics, where of course the age of the child varies, affects the outcome a lot. But we also have a general improved robustness plan, and that can mean many different things. So it's improved robustness towards different image artifacts and implants and different reconstruction algorithms, but also different kinds of CBCT images. And DLS is great. I'm of course biased, but it's great and our customers agree and they're saving a lot of time. But the full power of DLS can be reached when you use it in together with all the other tools that we have within RayStations, but also in other products that we have. So together with the deep learning segmentation and the RayStation toolbox, but also deep learning planning, which is another product that we have within RayStation, you can reach full end-to-end automation. And this RayStation toolbox includes, for example, structure templates, scripting, protocols, and yeah, a lot more. There's so many tools you can use in there. And on top of this, we can have performance monitoring, which enables consistent and intelligent use. And automation and consistency also enables analytics. And what we see here is as a screenshot from another one of our products, which is Ray Intelligence, which gathers data on a cohort level. And by doing that, you can gain insights and find different pain points in your patient flow and further improve it. And you can also reach insights of, okay, are we actually gaining something from what we're doing here? And we recently published a case study with Iridium, which you can find on our website. It's great. I recommend you to read it if you haven't already. And they are using a RayStation together with deep learning segmentation, deep learning planning, and are very using a lot of scripting and structure templates. And they have automated their prostate flow end to end. And they used Ray Intelligence to analyze, okay, how are we actually doing there? Has this been a success? And then they could see that they were down almost 50%, both in terms of patient modeling and in dose planning by using all of these tools. So end-to-end automation isn't in the future, that's actually here today. But what's coming next is to ensure that we can deliver end-to-end automation for all different sites of the body and also make that available for all clinics and not just the early adopters as it is today. So that is what we're working on now and hope to see in the future so that everyone can enjoy the fruits of automation and deep learning in different cases. Thank you.
Thank you, thank you, thank you. That's great. I always love to see the time scale because we do need to remember where we start and where we are now. And then you show this graph showing how much more and more patients, more and more users are using deep learning segmentation, right? So we compare with 20, we have over 2,000 in 2024. Would you say, like, what is the changing there? What is the aspect that contributes to that growth?
Yeah, so back in 2022, or even before that, really, it was very much the early adopters that used deep learning segmentation. We had many clinics that we had quite close collaborations on that were early adopters. But then they quite quickly shifted into everyone just expecting us to have all those structures. And if there were certain structures we didn't have, it was like, okay, but when are they coming? We want them now. And now we see instead that people are like, okay, great, all these structures exist. But now we're afraid that our clinical specialists trust them too much. Like, how do we know that they're actually performing well? So now they want this performance monitoring to ensure that they're actually using the tools in a smart and safe way. So it's been a very quick shift, which has been very fun to see.
All right. So we see that shift into having more trust in technology as such.
Yeah, a bit too much.
Yeah.
Too much trust. They
Even
are
too
afraid of
much
it.
trust. Yes. Aha, I see.
We are less afraid of that, but
Okay, yes, because I know, like, in general, not only in radiotherapy, artificial intelligence as a technology, it is still being seen as something scary or threatening. So it is a challenge to change these attitudes into showing how beneficial it could be in a safe way.
yeah, I think as soon as they start using it, they realize how powerful it is and how much time they save and actually how good the structures are. And the clinics are testing the models before they actually go live with them. And then they see, okay, this is actually really good and will save us time. But then they need to, of course, ensure that they use them, actually review the structures, which they should do.
And you mentioned one thing about consistency as well. Does that help for in when it comes to contouring, having deep learning solutions in the clinic?
Yeah, for sure. It's even if you have like local changes to a certain structures which doesn't align necessarily to what the model does, we see that having a common starting point means that all the contours you create from that are much more consistent, which is also a really great benefit.
And when it comes to our own models, do we take into consideration any changes after, let's say, we released a model? Do we then leave it as it is, or we do come back to that?
No, we come back to it all the time, and depending on what feedback we get from the customers, we prioritize differently. But we do have a list now of structures that our customers have said, okay, but this we think can be better, or we use a different guideline, and then we of course want to improve that.
Great. Thank you, Anna. That's great to see how technology is coming to real world and having the benefits for the patients, for the users that we have out there. So thank you, Anna,
Thank
so
you.
much. Yes, and give it another round of applause. Yes.
Thank you.